Welcome back to the discussion and thank you for always joining us. This is three-dimensional geometry, KCSE 2024 paper 2 question number 19. And the question we have reads, the following figure shows a tent erected on a level ground. The roof A, B, C, D, E, F of the tent is supported by 4 vertical posts, P1, P2, P3, P4, each of height 2.5 meters. The ridge EF is 3 meters, is centrally placed. Further, we are given that AB is 11 meters, BC is 8 meters, and FB, FC, ED, EA is each 6 meters. Calculate part A, the length of the projection of FC on the ground, correct to 4 significant figures. We know the ground is below A, B, C, D, and therefore we are going to start by first making the ground by joining P1 to P2 and also using a broken line towards the point P3, and then now joining P1 to P4 and also direct to P3 like that. This is now our ground. From there we can start by drawing a line joining P1 to P3 so that we have the vertical line joining the 2 points. We can as well join A to C so that we can get a similar line like the one that we have drawn. We can call this point N. We can call this point O. We can also call this point even Z, such that we have OZN, then we have B, and finally we can have a point like Q here. Once we have done that, remember ON is going to be the same as AC. Since we need to find the length of the projection of FC on the ground, this is ON is the ground, but the projection of FC will be on the plane ABCD, and this is what we need. We need this line this way. So if we drop a line from F to meet this line, we can call this one a point M, such that MC becomes the projection of the line FC on the plane. Having done that, we can as well extend this line from M to go and drop at this point here, such that we have 90 at this point. And therefore, if I call this point a point K, KN, I can call this point K. That means KN will be equal to MC, because the ground is KN, but KN is the same as MC, and therefore we are going to find the length MC so that we can have the projection of FC on the plane as MC. So what we are going to do, if we drop a line from the center of AD to the center of BC, we are going to have a line that is going to run this way, such that from this point M to a point at this point, we are going to have the distance as 3 meters. That means what is going to be left will be the total, which is 11 minus 3. We divide by 2 so that we can get 8 over 2 becomes 4, meaning this side we have 4, this side we also have 4 meters. This line that is running from AD to BC will intersect BC at 90 degrees. This becomes the midpoint. We can call this midpoint a point like W, such that WC is going to be 4. We also have BW being 4. From here, we are going to use this right angle triangle created to calculate MC, and by so doing, we could have solved part A of the question. And therefore now, we are going to have a triangle that looks like this. This is a point W at this point. We have a point M. We also have a point C at this point. Having done that, we are going to have MW. We are going to have CW as 4 and MW as 4, such that to get MC is going to be equal to the square root of the height squared plus the base squared, giving us a total of 16 plus 16 will give us 32, and 32 square root will be equal to 5.6568. But correct to 4 significant figures, we are going to have the answer as 5.657 meters, and by so doing, we have calculated the length of the projection of AFC on the ground, and the ground in this case is KN. Remember, we can argue that KN is the same as MC, and that is equivalent to 5.657 meters. Once we have done that, we can now go and work on part B of the question. And part B of the question, we are supposed to find the height of the ridge EF above the ground. That means we need the length KF. The length required will be KF, and in this case now we are going to use the triangle. We are going to use the triangle MFC. We are going to use the triangle MFC to find the height from M to F. Then we add M to K. In this case, we are going to use MC, which is 5.657. We also have MF. We have FC as 6. And therefore now to get this height, we are going to use Pythagoras theorem, where H will be equal to the square root of 6 squared minus 5.657, and this one is going to be equivalent to 1.9995, which is approximately 2.0 meters. That means for us to be able to get the length KF, we will have to add MF plus KM. Remember, to get Km, it's very simple because Cn is 2.5. That means Mk is going to be 2.5. And we have gotten MF to be 2. And therefore, the total line is going to be equal to 2 plus 2.5 which is going to be equal to 4.5 meters as the height of the ridge from the ground. Once we have done that, we can now go to part C. In part C, we are supposed to find the angle between FB and FC. This is the angle we need, and therefore we are going to start by drawing that particular triangle. That is the triangle that is going to look like this. This one is going to be B, this one is going to be C, and this one is going to be F. We need the angle theta at this particular point. So remember, BC is 8 meters, sorry. This is 6 meters, this is 6 meters. So we are going to split this into 2 such that we have 4 here. Remember, the angle we need is theta. We can have this angle as theta 1. So that once we have that theta 1, we are going to find the size of that angle theta 1 by using opposite of the angle and the hypotenuse. The opposite is 4 over the hypotenuse 6, and this one is going to give us 0.6667. And for us to get theta 1, we are going to find the sine inverse of 0.6667, which is going to give us 41.81 degrees. And therefore now the total angle BFC will be equal to, this will be twice times 41.81, giving us 83.62 degrees as the answer to that particular question. Then finally we go to part D, where we are supposed to find the angle between the plane FBC and the ground. FBC and the ground. We are going to sketch again that triangle. So we are going to use FMW. This is what we are going to do. And therefore, for us to be able to get that angle, we have FMW, FM, then W at this particular point. Remember, we have MF as 2, we have MW as 4, and the angle we need is the angle theta here. In this case now, to get the angle theta, we use opposite over. Now since what we need is the plane FBC and the ground, we are going to use the common point, which is W here. And therefore, since we have the opposite and adjacent, we are going to say tan of angle theta will be equal to opposite over adjacent, giving us 0.5. And therefore, for us to get theta, we need to get tan inverse of 0.5. And this one is going to translate to 26.57 degrees, correct 2 decimal places. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome. Do not forget that the angle we are supposed to look for between FBC and the ground, the common point is W, and therefore we need this angle theta here. Thank you and welcome.